This lesson is going to introduce the very important concepts of equations, solutions, and inequalities, and what those vocabulary words mean and how they are similar to and different from what we've already covered so far in this Algebra 1 sequence. When you think of an equation, and every single time I do this, like the first thing I write does not write right. That is so weird. When you think of an equation, you really need to think of that equal sign. So an equation is formed when an equal sign is placed between two algebraic expressions. And up till this point, we have only been dealing with algebraic expressions. An algebraic expression has no equal sign. An equation does. And it's really, really important that when you're doing algebra that you're paying attention to whether there's an equal sign or not. Many of my Algebra 2 students will put equal signs into expressions for however they're thinking about it, or they'll get to the end of a simplifying problem and it'll look wrong or whatever, and this equal sign will appear. Or we'll be working with an equation and we'll drop the equal sign out. And that is a critical, mission critical kind of thing. We need to make sure that we know when we have an equation and when we don't. It's also important to know that when you're dealing with an equation, we talk about the left side and the right side. And I want to be really explicit about this. So you've got your left side and your right side. If you do not have an equal sign, you do not have sides. And so if you just have an algebraic expression of some sort, it's not meaningful to talk about the left and the right side. What are you using as the kind of point where you're breaking the left side from the right side. And we only use this expression too when we're talking about equations. I have had students who talk about the sides, and what they mean is the numerator and denominator of a fraction, like the top side and the bottom side, and that's just not how we talk about it mathematically. So if somebody is talking about the left side and the right side, or very frequently you'll hear someone say both sides, this is what we're referring to. We're referring to the left side and the right side of the equal sign. So I'm going to give you some examples of really, really simple equations. So this is actually a really simple equation. 4 minus 1 equals 3. These are very, very basic and simple algebraic expressions, but they are expressions because remember the definition of expression is just like a collection of variables and numbers that have operations between them. And so you've got the subtraction operation, and here you have a number, and we don't have an operation, and that's okay. It's just super, super basic. Then you can have equations that have variables in them. So for example, 3x plus 1 is equal to 7. And this is what we would call a two-step algebraic equation, and we haven't gotten there yet, but that is what that would be called. And here's another example. You could have something like a plus 3 equals 3 plus a, which I hope makes sense to you if you pause the video and think about that for a second. So when the variable in an equation is replaced by a number, then the resulting statement could be either true or false. A true statement is something like 3 equals 3 or 4 equals 4. A false statement would be something, here, let me write that down. So a true statement would be something like 3 equals 3 or 4 equals 4. A false statement would be something like -2 equals 5 or 1 equals 0. So you've got true statements and false statements. When a number is placed into an equation and the equation ends up being true when you simplify it, that is what's called a solution. So a solution to an equation is a number that when substituted in makes a true statement. And I'm actually going to asterisk that in a different color. I don't have a highlighter in this program that I'm using, but I'm going to circle it. Okay, that is so critical to know what a solution is. And a lot of my students in higher level math will get a problem and it'll say like solve, but they're missing the sense of what that direction means for them to do. Like, what am I looking for? If you're asked to solve or you're asked to find a solution, what is it exactly that you're looking for? Where you're looking for the numbers that when substituted in are going to give you a true statement. And what's so important is that this is true for all kinds of equations. In Algebra 1, we're going to study mostly two different families of equations in Algebra 1, but there's lots and lots of other families. And once you learn how to work with the first couple families, it becomes very easy to like layer on the new families. But that definition of a solution is true for all families, like all equations. So sometimes if you're dealing with an equation that you've never been taught how to solve, you can come back to this definition and figure it out. So what we're going to do in this next problem is simply check to see whether a number is a solution for a problem. So here's the question here. Is, or let me make that R. Are 2, 3, and 4 solutions to the equation 4x minus 2 equals 10. Okay, and so what we're going to do is determine if any of those numbers are solutions. So remember the definition. A solution is a number that when substituted in makes a true statement. So let's go ahead and we'll check the first one, which is the number 2. And at this point, this is a skill that hopefully you have where you can take a number and then plug it in and then use order of operations to simplify it. So we know, and what we do is we simplify the left side and the right side separately. Okay, now, fortunate in this one, we don't have to simplify anything on the right-hand side. So we just have to simplify the left side. So 4 times 2 is 8, and 8 minus 2 is 6. That is false, so not a solution. And I'm going to use the abbreviation SOLN for the word solution. Next one is the number 3. So we're going to go ahead. And what I'm doing there with the color is I'm just changing the color so that you can see where I had the X, I'm plugging in the number. So wherever the X was, that's where the 2 goes. Wherever the X is, that's where the 3 goes. 4 times 3 is 12. 12 minus 2 is 10. And so we get 10 equals 10, which is a true statement. So that is a solution. And then the last one, we have 4. And this time we're going to plug in a 4. Minus 2 equals 10. 4 times 4 is 16. 16 minus 2 is 14. And that's a false statement. So that is not a solution. And I said I would use SOLN as an abbreviation, and then I stopped. Okay, and that's pretty much what we're dealing with here is to be able to plug in and check whether or not something is a solution. Now, some equations have one solution, some have more than one solution. Sometimes you can actually do these problems in your head. So take, for example, x plus 2 equals 6. So what we're looking for is a value of x that when you add 2 to it, you'll get 6. So you think, well, what number plus 2 gives me 6? And a lot of you could figure out in your head that x has to be equal to 4. So 4 would be the solution. So let me write 4 is the solution. Let's look at like x minus 3 equals 4. So what number subtract 3 from it would give you 4, and I think most people would figure out like, oh, 7 is a solution. Here we have 2x equals 10. Now remember, this is multiplication right here. So 2x is 2 times x. So what number times 2 would give you 10? Give you 5. 5 is the answer there. So 5 is the solution. And then let's look at this one. X divided by 3 is equal to 1. So what number divided by 3 gives you 1? Well, what over what? Even think of your fractions. 3 over 3 would be equal to 1. So 3 is a solution. And those can be done in your head. Now we are actually going to go through like a method or a plan for how you can do those problems, because ultimately, even though you can do them in your head, we want to have like a method, because I can give you yuckier numbers or like fractions or decimals or things that you wouldn't be able to look at and just do them in your head. So we will like kind of flesh that out a little bit. All right, now let's just take a look at the inequality symbols before we move on from this. So the inequality symbol, this is a thing. So you've got this, that just means is not equal to, and it's not usually what we mean when we say inequalities. Technically it is, because prefix in means not, so inequality would be like not equal. So technically it is an inequality. We do use it when we get to talking about things called restrictions on the domain is where it comes up, but that is way, way, way farther than where we are right now. Usually when we talk about inequalities, we're referring to these symbols here. And I find that like students have a lot of confusion about what this symbol is. And I've even seen like lessons online that take this and just like really make it hard, and it's not supposed to be hard. So let's just quickly go over what these symbols are. First of all, it's not symbols. Like technically it's like one symbol, and it can just face two different ways. And then we always read it left to right. Okay, so when you're reading an inequality statement, we read from left to right. And so you just might encounter the symbol oriented differently. The symbol always opens towards like the bigger number. Okay. And so if you've got like this statement, 5 is bigger than 2. And so it opens, like you hear about like the alligator is hungry, okay, and eats the bigger number. So when you read it, because the symbol is oriented this way, it means the smaller number is on the left. So you're going to say 2 is less than 5. 2 is less than 5. It's not because it's like a different symbol. It's just because you're reading it from left to right. Or you could have it this way. This is technically the same statement, except now you've got the bigger number on the left. So when you read from left to right, you would read 5 is greater than 2. So just kind of remember, like, whether you say less than or greater than, just it has to do with reading left to right. So like, where's the bigger number? Now, if you've just got integers in there, it's usually not an issue. Where it becomes an issue is when you have a variable in there, and then students, like, you can't just look at it and see which number is bigger, and so you have to know how to read it. If you see the little line underneath, the little line is actually the bottom part of an equal symbol, and so we just add or equal to. Okay, so less than or equal to, and it just means that being equal is another option for making the statement true. Like it could be equal, like we have over here, like maybe they could be equal, but less than would also work, or greater than would also work. So let's take a look at a couple of inequalities here. So we've got 3 inequalities, and we want to know is for a solution. Okay, and then the first one is 2x minus 1, and then notice how it's oriented. So it points to the smaller one and opens to the bigger one, which means this is smaller. So when I read it, I'll say 2x minus 1 is less than 8. For the second one, it's x plus 4, and then notice the orientation of it. It always opens to the bigger and points to the smaller. So this means this is bigger. So when I read it from left to right, I'll say x plus 4 is greater than 9. And then the last one is x minus 3 is less than or equal to 1. All right, and then definition for solution. Remember back here, I starred this and circled it and everything, and I said this is so important. That idea is just super important because it doesn't change. It's true for everything, and it's true for inequalities. So to test whether this is a solution, we are going to change it. I don't know what I'm doing. Okay, we're going to plug in 4. And then look to see if we get a true statement. So 2 times 4 is 8. 8 minus 1 is 7. And I get 7. And then I have that symbol. Now remember, you're reading it from left to right. So it points to the smaller, opens to the bigger. So when I read this, it's going to read 7 is less than 8, which is true. So 4 is a solution. For the next one, we have 4 plus 4 is greater than 9. Well, 4 plus 4 is 8. And I end up with this. Now remember how you read it. It eats the bigger number and points to the smaller number. So as I read this, I'll say 8 is greater than 9. Well, hopefully that doesn't ring true. That is false. And so 4 is not a solution. And then the last one, we have 4 minus 3 is less than or equal to 1. 1 is less than or equal to 1. Now, 1 is not less than itself. Just want to be really clear about that. But it is equal to itself. So 1 is equal to 1, which in this case is true. And 4 is a solution to that inequality. All right, so I'm going to, on the next slide, put some problems up for you to practice on. And the goal of this is to just establish what is and is not a solution to an equation or inequality. Okay, so here are our 8 practice problems. And I did skip over the mental math ones because I don't want that to become too ingrained in how you're approaching the problems. But just in case you can't read anything, is 4 a solution to 3x plus 1 equals 13? Is 2 a solution to 5x minus 2 equals 11? Is 1 a solution to 6x minus 4 equals 3? Is 5 a solution to 2y plus y equals 2y plus 5? Is 7 a solution to x minus 2 is less than 6? Is 4 a solution to 5 plus x is greater than 8? Is 1 a solution to 4x minus 3 is less than 0? And is 9 a solution to x minus 7 is greater than or equal to 11 minus x? So pause the video here, work these problems out, and then we'll go over them and talk about them together. Okay, so what I did was I copied these over and just erased some of them so they're going to kind of work down the page in a really weird way. That remember what the definition of solution is. It is the value or values of a variable that when you substitute it into the equation will give you a true statement. So for this first one, we have 3x plus 1 is equal to 13, and we're wanting to know if 4 is a solution. So I'm going to put in the 4 in place of the x. 3 times 4 is 12. 12 plus 1 is 13, and I get what is known as a true statement. So our answer would be yes, 4 is a solution. The second one, is 2 a solution to 5x minus 2 is equal to 11? So I'm going to take out that x and plug in a 2. And then notice for a moment how math starts to build. So hopefully this isn't feeling too hard for you, but A couple of lessons ago, the entire problem was on how to simplify this. Now that we've gone over how to simplify expressions with numbers in them and do correct order of operations and substitute in, then like layering on the next topic shouldn't be too bad. If it is, you want to go back and review some of the earlier lessons and make sure you get some additional practice. 5 times 2 is 10. 10 minus 2 is 8, and I end up with 8 is equal to 11, which is a false statement, so that is not a solution. And then the last one is 1, a solution to 6x minus 4 is equal to 3. So we plug in a 1, 6 times 1 is 6, and then 6 minus 4 is 2, and that is false. 2 does not equal 1. So that's not a solution. Number 4, is 5 a solution to this lovely hot mess? So 2y plus y is equal to 2y plus 5. So we're going to take the 5 here and plug that in. So we'll have 2 times 5 plus 5 is equal to 2 times 5 plus 5. And a lot of you right there are going to say, wait a minute, that's the exact same thing on both sides. Do you really need to go and further and do more? No, not really. But we will for practice. 2 times 5 is 10. 2 times 5 is 10. And then 10 plus 5 is 15. But if you were taking a standardized test or something, no, you would stop the moment you realized that that was a true statement. So this is yes. Next one, is 7 a solution to x minus 2 is less than 6. Remember, you're reading it from left to right. So in this case, the smaller number is on the left. 7 minus 2 is 5, and we get 5 is less than 6, which is true, which means yes, it is a solution. And then the last one here, we have 5 plus x is greater than 8. Remember, again, reading it from left to right because of the way that's oriented, it means the bigger quantity is on the left. So we're going to read is greater than. 5 plus 4 is 9. 9 is greater than 8, which is true, and that is a solution. Is 1 a solution to 4x minus 3 is less than 0? So we go ahead, plug in the 1. And we get 4 times 1 is 4. 4 minus 3 is 1. And remember the way we read it, it's saying that the smaller number is on the left, bigger is on the right. So 1 is less than 0, which is false. So no, that is not. And last but not least, we have this. So is 9 a solution to this? So we plug in a 9 each place. Each place you have an x, we plug in a 9. 9 minus 7 is 2. 11 minus 9 is 2. And it says 2 is greater than 2. That's false. But 2 is equal to 2 is true, and it can be one or the other in this problem. So yes. So there's our lesson on solutions to equations and inequalities.